logged on to the call. This is Ramanan, Mission Director of Atal Innovation Mission. First of all, I hope all of you who have logged on to this call, young budding innovators, startups, organizations which are desirous of making an impact to the space sector in India as well as across the world. I hope every one of you is hale, healthy, and hearty under these difficult COVID-19 circumstances, and that all of you are practicing the safeguards advocated by the local government, by the local institution, and by the organization in which you are a part of. I'm sure this COVID-19 will soon come to pass with some of the finest brains across the world tackling the problem and curative, assistive, or preventive solutions aiding in the process. I am delighted today on behalf of Atal Innovation Mission and ISRO, the Indian Space Research Organization, to be able to introduce three very distinguished panelists who are going to be talking about the opportunities and the challenges that innovative young startups have in the space sector. As all of you are aware, the Atal Innovation Mission has been set up a couple of years ago in order to create and promote an ecosystem of innovation and entrepreneurship across the length and breadth of our country. It has been doing so through the launch of several initiatives at a school level by launching thousands of tinkering labs that enable young students acquire a problem-solving innovative mindset, by enabling them to expose and tinker with and play with emerging technologies like 3D printers, robotics, IoT devices, miniaturized electronics, augmented virtual reality through do-it-yourself kits, so that they can use these technologies to create prototype of solutions for problems they see in and around the community. Thereby, they acquire a problem-solving, innovative mindset as compared to a rote learning mindset which has been cultivated over the years. At the university level, we have launched hundreds of incubators which are fostering thousands of startups. And these startups are very important if you want to create a nation of job creators and not just job seekers. Indeed, India has been leaping forward in the Global Innovation Index. It has leapt from a position of 81 in 2015 to a position of 48 as of last year. And that's an incredible progress for a country of our size. And the fact that we are also having a $191 billion ITS industry, that is one of the largest export services industry in the world, is indicative of the knowledge capital and the intellectual capital that India enjoys. Also, we have been setting up community innovation centers across the country so that the benefits of innovation reach to the rural people, to the tier 2, tier 3 cities, not just the tier 1 cities, so that everyone is able to create innovations required by the local communities where they are there, and to be also able to use these innovations, replicate it, and scale it up for the benefit of these communities. As all of you are aware, India has more than 600,000 villages. We have more than 4,800 small towns and cities. We have only 8 tier 1 cities. And if we want to progress uniformly across, we need to ensure that we create hubs of innovation and job creation in every nook and corner of the country. We are also setting up and launching several challenges, which is why we are organizing this particular webinar. Atal Innovation Mission has been launching what are known as Atal New India Challenges. And these challenges are to stimulate product development and innovations in areas that can have national impact at a socio-economic level. We need to ensure that not only are we creating economic impact through our innovation and our country grows in its GDP, but we also need to ensure that the social divide, the economic divide, the digital divide that is there in our country between the haves and the have-nots, between the rural tier 2, tier 3 cities and the tier 1 cities is bridged. Only then we will be able to have sustainable growth for this country. And it is in that context that the Atal New India Challenges called ARISE, Applied Research and Innovation for Small Enterprises, has been launched along with 5 ministries just a month ago. And these challenges are in order to stimulate innovation, make in India innovations in the MSME industry and the startups. In particular, we launched 3 challenges along with ISRO. And this is very, very timely and momentous because recently on June 24th, the Union Cabinet announced that private sector can participate in all space activities. And ISRO, Dr. Sivan, in his address, said that ISRO would be supporting private sector extensively by allowing them access to key technology and research labs and to be able to make their innovations a success. Now, space and satellite technologies offers tremendous amount of scope for innovation and for applications in every sector of our economy, whether it is the agri sector, water management, affordable housing, smart cities, smart villages, healthcare, you name it. There are tremendous applications leveraging geospatial information systems as well as satellite technologies and space applications to be able to benefit the common man. And therefore, these are very important considerations for us. At the same time, India has been occupying a leadership position in the space sector through its various launches and has proven to the rest of the world how Indian space sector has been much ahead of its counterparts across the world in being able to drive frugal innovation and yet not compromise on quality. And therefore, we need to maintain that leadership. And the 3 challenges reflect a combination of that. The first challenge that we have launched is in the area of propulsion, green propellants, electric propulsion, and advanced air breathing. This is the first challenge. And you have to allow your imagination and your creative ability to see what are some of the problems that can be addressed through your innovation. The second challenge is on geospatial information. Geospatial information using and leveraging new technologies like machine learning, artificial intelligence, and these are very useful. There are so many applications, whether it is related to crop monitoring, weather forecasting, program evaluations, and so on. And the third area, which is an emerging area in technology, is robotics, artificial intelligence, and virtual reality, and AI, AR, VR systems, augmented reality and virtual reality system. There are tremendous amount of applications in robotics, AR, VR techniques supporting space exploration and outer space monitoring. Now, all of these are exciting challenges for the startup world and the MSME world to respond to. Please note that the applicant has to be a registered applicant. There have to be a registered MSME or a registered startup in order to be able to apply to these challenges. And the challenges will be closing on October 31st. So we have still a couple of weeks left before the challenges will close. And we are already seeing a number of people responding to these challenges. But today, we are having 3 very distinguished speakers and panelists. And we want to hear their views because they deal with the world of satellites and space day in, day out. First and foremost, I'd like to welcome Dr. Sam Dayal Dave, who is the director in IISU. He took over charge as a director of IISU in July 1st, 2017. Prior to taking over as a director, he was the associate director of IISU and the deputy director of advanced inertial systems area, which is responsible for the design, development, and production of advanced inertial sensors such as ISRO ring, laser gyro ILG, ceramic servo accelerometer CSA, advanced inertial navigation systems for LV Mk3, and precision scan mechanisms for spacecraft payloads. He has more than 27 years of experience in the design, analysis, and simulation of inertial sensors, actuators, systems, and mechanisms. Dr. Sam Dayal has graduated in mechanical engineering from the College of Engineering Guindy in Chennai, did his master's from IIT Madras and doctorate from IIT Guwahati in the area of nano finishing with plasma. He has been deputed as a mechanical expert for design review in other space organizations like CNES. He holds a patent titled Multiple Mass Tuned Damper for precision rotors and as the first inventor and recipient of the ISRO Merit Award and few ISRO Team Leaders and Team Excellence Award. We are also delighted to have Dr. Krishnamurthy joining us today. DrVN Krishnamurti has served as the distinguished scientist in ISRO and currently is working as a senior professor and registrar of the Indian Institute of Space Science and Technology at Thiruvananthapuram. Earlier, he has worked as a director, National Remote Sensing Center, NRSC, and also as a scientific secretary, ISRO. Presently, Dr. Krishnamurthy is facilitating and building payload sensors, small satellites, space-related systems, and for Gaganyaan. Besides teaching and research, overall administration, and expanding the infrastructure and facilities to meet future demands of ISRO and industry, he is also the chairman, Research Advisory Council for NCCR, Ministry of Earth Sciences. Dr. Krishnamurthy has significantly contributed during the last 4 decades in promoting remote sensing and allied geospatial technologies, navigation and GIS, communication and resource management, and in extending their use at grassroots level. We are delighted to have you, Dr. Krishnamurthy, sir, to join us on this panel discussion. We also have Dr. Jayan N, who is currently working as the Group Director, Cryogenic and Semi-Cryogenic Propulsion Engines Group, and is the Associate Project Director of GSLV in LPSC. He completed his BTech in Mechanical Engineering from Government College of Engineering, Trivandrum, and ME in Aerospace Engineering from the Indian Institute of Science in Bangalore. He joined ISRO in 1992. He worked on the Vikas Engine Design Division for first 8 years. Currently is responsible for the design and development of cryogenic and semi-cryogenic engines for different launch vehicles and delivery of liquid stages for GSLV. He has contributed to the development of the first indigenous cryogenic engine used in the upper stage of GSLV and the development of high-thrust upper stage cryogenic engine for new generation launch vehicle GSLV MK111. He is an ASI gold medal. He has won ISRO group awards and he has many other accomplishments to his credit. Now, we cannot have a more distinguished panel today to be able to share their views, their thoughts on both the challenges that we have launched for ARISE and what other things, opportunities they see in the innovation world related to the space sector. So we'll start off with Dr. Sam Dayal Dave. Could you kindly share your thoughts, sir, on this particular occasion and with relation to the ARISE challenges that have been launched?
Yeah, very good morning and very thank you for your kind introduction. Dear friends, Mr. Ramanan, my dear friends like our Dr. Krishnamurthy and Mr. Jain, and the host of other participants. Once again, greetings to all of you. In fact, as I was told, some maybe 5 or 6 minutes I will take just to introduce this topic. See, I will to save time. I will go straight to the topic of interest, what we want to discuss. See, primarily I want to discuss about robotics and artificial intelligence in space, potential applications. So initially, I'll just try to give a brief of whatever possible, what had been done or what is envisaged, possible roles in space sector for the robotics as well as its AI. Then probably I will just touch on what is can be done by MSCs or innovators and startups, what they can contribute. And I wanted to convey that these are only a glimpse of and what we are really, what we, my aim, if I have served the purpose is, you don't take this as any reference. This sometimes I will give some information only to tickle you into further exploring. So that is our aim. So you should never settle into what is this is the thing, but we should move on to a greater heights than what we are hinting about. So just give a overall, you see, if space robotics, if you see that microgravity operations for near space manipulation in the orbit, repairing or debris collection and removal, or some assembly of a telescope, antenna, etc. And creating an infrastructure activity with the aid of robotic systems. So that is one part. So here it can be an intravehicular activity. That means within a space station or within a crew module, a robotic system can do, or even the external where the repair etc. also comes in, or assembly of a big telescope antenna system, collective antenna system can be talked about. So their internal and external vehicular activity, astronaut as an assistant. See, one is to do mundane things, assistance. Another is psychological assistance, and feel free. The isolations can be taken away by another person with who can understand the humans. So AI-enabled free flyers. So if you are inside in zero G, you are there, you can really fly around. Just a fan will help you to move from one place to another. So those are control systems associated to it, and as companion robots. So basically, it can be said rovers, free flyers, robotic arms, humanoids. It can be another type of four-legged robotic element, individual, independent, which can cater to this activity. So next, for near space microgravity, the key focus areas I would like to highlight is electromechanical design and control. This is one area where it has got multiple dimensions. In that, microgravity locomotion, as I said, if you are inside a cabin, how you can fly around in the space, as well as if you are outside, how do you propel yourself and position yourself, and then your communication and that interfaces and corresponding teleoperations. So these are the other challenges. Then one biggest area of our thing is machine vision for inspection and assembly, including compensation. So this is one area where innovation only can solve and make it operational. That is a machine vision. And it is what we ultimately want is how a human will see, perceive, and act, and that fast. How that computing is done faster. So I will come to the other criticalities subsequently. Then of course the radiationing and the hardening effects on the electronics what we are using, and the miniaturization what is required. Those are the elements. Then the power sources and recharging, or how we can sustain this activity for a longer duration. See, you will not have opportunity to charge or do everything when you are really in space. Sometimes you will be able to generate your own power. Whether I will also talk about the challenges in this energy management. Of course, thermal and other the harsh environment of the space. So here, even the robotic arms that comes also, we are talking about it, the near space microgravity. So planetary robotics, this is another area where we are about manipulation, landing in another planet, and then mobility in that, sensing, perception of planetary exploration, as though a human goes in and collects samples, etc. How we can replace a human. So these are the many challenges. That is another area of it. So command and control with limited bandwidth. These are challenges which has to be overcome. Yeah? So what we are trying to do is we want to simulate or emulate whatever we are doing in ground, the exact same thing in a planet, but with all these limitations. So there only this collaborative robotics and human robot system design and development. These are some of the key focus areas of challenge. So then if I sum up in a space, the environment, of course, the environment is harsh, radiation is there, contamination sensitivity, thermal extremes, and even zero G gives you a lot of challenges. Then ability to sustain launch loads and vibration. So if you want to send any system with this miniaturized and made, this should be hardened, or should be able to sustain the launch loads and vibration and reach the space, because going to space has got one set of extreme challenges, whereas on reaching there is another set of challenges. Then communication delays, microgravity manipulation, limited computational power. This part I wanted to very highlight to the young entrepreneurs also. See, the computation power is not infinite. Here you have the capability of cloud computing and all that, or any huge supercomputer. All those things are all is possible, whereas you have to carry a small computer, but it has to have the extreme high performance. So the algorithms, whatever you develop for a ground application versus there, see, it is not only things are to be energy efficient, they are to be computation efficient also. So then testing in microgravity, planetary analogs environment, and robust and reliable system, because redundancy we will not have much opportunity for repair, and of course we are bringing in more repair systems, but we don't have, so the reliability has to be extremely high. Now next, as I mentioned earlier, this computer vision, so for autonomous navigation and path planning, and even uneven terrains or unknown areas, etc. So this is one area which is a tremendous potential, and here keeping the computation limitations, miniaturization requirement, and this, but moving more and more towards with artificial intelligence and deep learning enabled, and how we are moving closer to the human capability with the type of resources what we can really carry to the space. So I want, because this is an area, it's a software innovation is there, hardware innovation is there, and other so in electronics miniaturization innovation is a requirement, and here the people can think freely, and that lateral thinking will help to come out with solutions, because this is an area I think that our India has got a great potential, and we should reap to the best of possible. Another is custom solutions for software packages and robotics algorithms. So there are institutions or companies are going to involve in more and more complex activity. So definitely in abroad, the foreign countries, many countries, developed countries have different solutions available, where in this area also we can have modeling and control solutions can be packaged, so that for a different environment this also can be made use of. Another is see this collaborative robotics. This is a mixed reality solutions, that humans and robot contactless collaboration. So how exactly we can bring in the humans, even though physically you are not present there, or the human is not present there. So this is a very challenging. Here is the sky is the limit for the imagination. So these are areas which are not at all explored to the fullest potential. Why I want to tell probably the fresh minds is the people who are involved, we are more aware of the constraints or difficulties, whereas this only I want the listeners to be aware of gross limitations, but the thinking process should be such that how to overcome and achieve 100% collaborative robotics experience. So this is one great area where a lot of thinking process of our young minds will help. Then of course telerobotics. See, this is not only in space or even in a ground application, but with the space sector through satellite links, even in a remote, you can have even a strategic application on a defense or anywhere. You can have concepts of group of robots with a master robo and performing it with a base station connected through satellite. So here the challenges is what? It has to be a miniaturized things. It has to be highly energy efficient. So that means in our concepts of building, I will do a little more later, of that we have to be energy efficient, computation efficient. So with everything, the efficiency of the systems what we develop, efficiency of the algorithms what we develop, these are what the challenges that is ahead, which can be mastered. Then, of course, artificial intelligence solutions here also is even you can have packaged solutions available for a situation which can be integrated into the overall. Somebody should be able to buy and bolt to a system to make the total system operational with efficiency. So a developer can really focus on newer algorithms and package it into with both software and hardware solutions, ASIC, or even the fast development cycle is now possible with electronics. And some of the areas where India had been lacking is with respect to the electronic components. Now that is being totally overcome with the presence of ASIC as well as our own Shakti or other processors that are coming up in various forms and fits. So we should be able to think such that even high performance platforms, that's what I said. This is, I just mentioned about CPU, GPR, these are all a known thing. I want people to think parallelly. The message is it should be energy efficient, it should be miniaturized, and it should be highly computing intensive capability. And of course, the deliverables like whatever I mentioned is with respect to the software, algorithms, and high performance computing platforms. So these are some of the areas that what is really can be posed for the community of our innovators and who are eager to plunge in this area. This area is really very promising, and you have and next part is with respect to hardware and software together. So sensor development. See here the sky is the limit, and the biosensors, all these things are all you have to look at the nature and come out with anything, any concept, anything becomes what is associated with nature. My personal perception is we are able to adapt into a system very easily compared to some physics principle from the earlier days. We make sensors only from the physics, whereas now of course there physics is behind it, but the bio inspired sensors are a great challenge as well as a motivation, and there is a great scope for it. Similarly, smart actuators. See, very high torque outputs or requirements are there in different scenarios, and they should be efficiently controlled. But at the same time, they should be rugged. When they are interacting with human, they should be soft, and but at every point of time, they should be able to recover the energy back. So every activity, see, any robotics independent when you do, unless the power is available, they no more they are of use. So how we are able, for every action, you walk 1 mile, you should at least 3/4 of a mile energy requirement should be collected back. So this is a type of approach where we in every design of actuators. So this is a big challenge. They are only basically hybrid of this hydraulic and electromechanical actuators come into picture. So here also you don't need to go for stereotypes. The concept is how do I recover the energy back? So for that, sky is the limit for your realizing such actuators. Then, as I said, the miniaturization of electronics and energy efficient electronics. This is a very area. Whatever that has come to my mind, 3D packaging, etc. I have put, but much more beyond can be done. And so another is in this area, test stations development. So see, whatever we want to do in a planet or even free activity, see that earlier, see the concepts like future, suppose you go to moon, establish a base station where you can do fueling or store fuel. so that the next further travel can be from moon as a base station. So such things, there the operations are to be done by robots. So such a concept, so this has to be simulated in ground, simulating most of the zero or lower G conditions, etc. So there, this microgravity simulation test beds, these are all very demanding, as well as for collaborative robotics, including mixed reality test stations, indigenous motion capture system development. These are areas where with the spherical air bearing, planar air bearing, and this capturing that mixed reality test stations, these are all very, very essential when we want to do reliable space robotic systems. So when we are able to do all this and simulate, then definitely with much reliability it can be done in space. Of course, this is additive manufacturing should play a major role. There, additive manufacturing techniques adaptable for these things. Even it should be in orbit repair, where you should be able to realize a component and replace. That sort of that is the one area where a really great scope is there, where things which cannot be seen, like even a fabrication of a big antenna system in space. So these are some of the big challenges that is there. So when you say robotics, you should not conceive as a humanoid or manipulating arm, etc. It has to be a daily walk of life things activity, that manufacturing activity in ground, certain things which can be done much wider scale, which can be manufactured without the difficulty of taking such huge systems from here to launch, etc., and deploy. Whereas you can even build your own systems there. So there, all this, the bottom line is cost effective, optimizing size, configurability, faster development time, and ease of integration. So this is the bottom line which will drive all this area. Okay, so then future prospects, as I said, I talked about biologically inspired sensors. Now you can even biologically inspired robots, soft robotics, or reconfigurable. Reconfigurable when it comes, even your spacecraft can be reconfigurable. Spacecrafts can be built from the same concept. So these are some of the prospects where I only wanted to tip of the iceberg only I want to highlight. Rest of it, the iceberg, it lies in our young Indians. So that is what we want to really stir and make use of it. So thank you for giving this opportunity also, Mr. Ramanan. Thank you. Over to you.
Thank you, Dr. Sam Dayal. That was a fascinating insight into the possibilities of robotics and AI, AR, VR, ML-based solutions that we are all looking for. And I think you very comprehensively brought out the various aspects of both space exploration, solutions that are required, how it's a combination of hardware, software, sensor technologies, robotic technologies, mixed reality solutions, and the various challenges that are out there which need to be addressed. And it was, I think, fantastic for you to give practical examples of where it is going to be used. You also highlighted the importance of configurability, efficiency in energy, ability, usability aspects, which should be very easy to use. At the same time, it has to be highly reliable. It has to be highly cost efficient, and all the other factors which need to go into the innovation. And as you rightly said, sky is the limit. You allow your imagination to run high and don't be limited by what is just presented to you. Go further deep into the subject and you will be able to come up with the innovation needs as well as the innovation that is required to address that. So it was fantastic. Thank you so much. I now request Dr. Krishnamurthy to share his thoughts and views on the challenges as well as the opportunities.
Thank you, Mr. Ramanan, and for this opportunity given to me. First of all, we are talking about Aatmanirbhar Bharat. And we are looking in, because that started as a startup and stand-up earlier. And there are a lot of other things which, because we are talking about geospatial technologies, AI, machine learning, how do you do predictive analysis. So in these areas, we all know about. But first of all, we should know where is the need. So the government, even in 2015, the Honorable Prime Minister has a national conference where he brought all the administrators across the country, including the chief secretaries and also a few technocrats. And with 86 ministries, there's a discussion on what is the need of geospatial technology, that is especially the space technology, for various applications. These ministries includes health. These also ministries include skill development. I'm telling the odd numbers. And you also have like agriculture, urban, these are all traditional, water resources, etc. That these are all the traditionally where people are using and how we can breed it out. Out of that, there is around 170 projects have come. Okay, there are on planning, monitoring and evaluation, decision making, citizen centric, and technology development and other things like that areas. And also, there's also a group of secretaries discussion. Suppose if you want to do many of the developmental activities, so there's a group of secretaries also has been formed by the government, and where they brought in, there are 8 groups which has been made, and within the 8 groups, there are a lot of applications which has come. That means these are the need. When there's a need, you have to look from what data you will use, what process you will use, and what applications will use. This is where we look in the opportunities. Now let us take a couple of examples in which where requirement is there. And when we are talking about an enterprise, we are looking at an investment. So who will invest on you? So first, let us attack 2 things. One is the tax collection. How do you assess cess and tax collection? So the water use. So there are certain bodies which irrigate areas, especially Krishna Development Corporation in Maharashtra, or Godavari Development Corporation. I'm giving you a few examples. Who actually put cess for use of water? So how do you assess this use of water from the space-based systems? Because you are aware, we have one of the best satellites which is launched in 1995 called, and it is now completing 25 years of celebration, that is called IRS-1C. That's from the same satellite you get a resolutions of varied resolutions, but covering large areas. That means in every 5th day, one shot, you can see almost one state. And also the another payload will see a given area or a district. And then the other payload will look into few of the blocks. And now that has been evolved into a system called ResourceSat. That is called 3-tier imaging. India is the first country to start that kind of an innovation in 3-tier imaging. The reason is, once you map something in detail, second time you don't have to go for the detail. That is where your AI and machine learning comes into the picture. That means you are looking for where people are growing sugarcane. I'm giving you an example. So when the sugarcane is a crop of 12 months, 16 months, and 18 months. So this is a little bit, as my friend Sam Dayal also mentioned, that you need to know a little bit of biology always, like agriculture. What is the crop growing periods of different crops? What are the different crops which they put in intermittent? They put some onion, they put some sunflower, they put some gram. So these are the intercropping mechanisms. So that means we know there's a heterogeneity in the total system. And how do we graduate in learning that in a given system, how do you do this kind of a water cess collection? And this is a live example which I was telling you, because you're all industry forward-looking applicants. This happened something in 2001, 2002 framework. So why I'm telling you this example, which is primitive, but it has a use. And now you have to think from that when I tell the host of applications which is available to you. That time is a few limited. Because that is time is a government of coalition which is looking for money to run their government. So one of the things which is if you are able to get the cess collection from Krishna Development Corporation in a much bigger way, because they are only getting some 35 crores at the time, but that has a huge potential. So we said we will give you this input at 2 levels. One is at a command level. That means you'll know how much cess can be collected. And you may be aware how things have changed now, I do not know, but at least 10 years back, it is 3,600 rupees per hectare and to 900 rupees per hectare, depending upon it's a lift irrigation or a canal irrigation or by a borewell. So our job is, we're not going to do that. We're going from the satellite imaging, looking at how much people are putting on the sugarcane. So we know exactly if a sugarcane crop, what is the crop water requirement. For every crop, we know the crop water requirements can be calculated. These are all set formulas which are available. Once you know, these people are using it, and how do we know exactly who is the farmer? See, please understand, this is where the crux of the problem is. Who is the farmer on which you want to put through? That is where we understood that cadastral maps to be georeferenced. So we georeference the cadastral maps. So, but the selling idea for the state government is, it's not that I will do a project for you for 20 crores. That doesn't give a business opportunity. Business opportunity, you invest on me 5 rupees per hectare. I will ensure that you will get 3,600 to 900 rupees per hectare. That is our trump card. Okay, this is where when late Vilasrao Deshmukh and President Sharad Pawar ji, so we had to go and discuss with them and show how the bonds which has been shown as Krishna Valley Development Corporation bonds, how the bond value will rise if you are not taking investments from outside, but you are self-generating the investment. This is the concept in which you had to go. And that was successful. But then we also, first year if you put in 5 rupees per hectare, next onwards it will be 2 rupees per hectare to 50 paisa per hectare. What is the confidence in bidding for that? Because we know the Resource Act has a different resolutions in which covers large area. Once I have a database with a very detailed information, subsequently you don't need that kind of a detailed information. That is where the machine learns that this is the pattern of crops which is being grown. And these are the people who need to be taxed regularly. Or there are certain other people or the farmers which has to put. And you'll be surprised. The very first year after this has been introduced, very partially, there is some 380 crores, which is what was previously coming as 35 crores from a command areas of what is nature. So there's a governance which brings in, gave revenue, and that is where the state governments will be interested in taking up such activities. So this is what I am telling you of a very old example. But now where we do stand? That is a supply-based irrigation. Now we are not looking at supply-based irrigation. We are looking for demand-based irrigation. That means exactly even for a sugar cane, you don't have to put flood irrigation. It has to be dripped exactly how much. So today there are satellites which are giving you almost every day the information. Or you don't need everyday information. Even every 5th day you get an information of that crop. What is its status? What is the requirement at that stage of the crop growth? And if you are giving a solution, you are the best fit. And for example, now I will get into the taxation. Another one is urban taxation. Urban taxation without investment. In geospatial technology, you don't have to invest much. You only need to have ideas. You need to have your laptop. You need to have a connection. And you need to access data. And then how do you make your brilliant ideas in bringing up simpler solutions where the other people are struggling to do something? Because all this job cannot be done by a governmental agency. These all should be private agencies like you, who are all coming with what all the investments which you are looking for. For example, in the government of Telangana has used the Bowen platform alone. We always think we need very fine resolution data. Best 25 centimeters. You have more resolution, more noise. Please understand this. That means there's so much of data which you cannot avoid. So here, because government policy tells on public domain, I can put in only 1 meter resolution. So whatever our 60 meter or 50 meter data, we have put it at 1 meter. For 77 of their urban local bodies, they reassessed the urban taxation. And with little training for their colleagues of the planning itself, then the secretary, they looked at, and almost the next year it doubled. But that is not the hidden story. Actually, there's much more. In fact, this is where you have to bring into 3D GIS type of a thing. And 3D GIS means don't look at, I'll use a laser. You don't have to use a laser with your mobile. You can make overlapping images of a building and a software which we developed indigenously by our students only, for engineering students, actually that. There's a software called Trivum. You take some overlapping photographs with your mobile and the building structure comes in. And what is the extra areas which has been constructed? What is the volume of the building? And you can superimpose these on the satellite images. And Bowen platform is available, our own platform, on which you can superimpose exactly the building blocks and show this is the total area, what is being taxed, reassess yourself. So now the taxation, also government has given liberties. You reassess yourself once again and tell, yes, I made a mistake or I didn't know, and do certain things. And there's a big value of money. Wherever such money is there, you make your products and services. and putting through. Whereas what is your greatest opportunity in this country is you have a huge heterogeneity. In nature has given India the biggest heterogeneity. That means you have Eastern Ghats, Western Ghats, East Coast, West Coast. You have a cold deserts, you have dry deserts, you have a central India where you have rain shadow region, and then but still irrigation is happening, and you have high variability of rainfall. So there are n number of systems, and you have islands, Andaman, Nicobar, and this thing. Our continental shelves are different. So there's a huge amount of heterogeneity where you can play with, but there are a lot of other countries where there's a lot of homogeneity. Europe, Western countries, and then other systems have more of homogeneity. So whatever you try here, your model, straight away you can implement. How you can implement, you may ask me, because all Indian satellites are global. Please understand, every satellite is global. It is revisiting the entire world. Our CortoSat-1 has made one of the best digital elevation models for the entire world. But from ISRO, what did we look for? We are not looking for mapping, land use, land cover. These are all old stories. Today, we talk about food security. In food security means what? What are the crops which today we are able to assess 1 month before the crop harvest? What can be produced or what area which is occupied? And if the produced there, how it will get distributed, where it goes in, or how the fertilizer will move in. And this fertilizer movement is today is not NPK. It is micronutrient blend fertilizers, and it is different for different crops in the same area. So there's a great challenge, there's an opportunity. That's where the government has told soil health cards. But soil health cards has been broadly interpreted by people, and 3,600 entrepreneurs has to be started. But then this information, while giving to the farmers, as Mr. Ramanan has mentioned, that we should have equity of information distribution for people. But actually this information will be purchased by the fertilizer companies to know exactly where the demand for micronutrient blend fertilizers. Then comes your chain for the total chain of operations. That's where your network analysis comes in. That means at the source of a plant where you are making this fertilizer, how it will move to the different sale points and to the farmers ultimately. And what is the shortest routes you can give? And when floods, etc., that is, what is the optimal routing you do? This is all a project which we did for IFCO quite some time back, but that is on NPK based. But now we are talking about micronutrient blend based fertilizers, what is needed. And you cannot use continuously, like we cannot take vitamins continuously. You cannot do that kind of a thing. So you have a water security. I was telling you about the demand-based irrigation scheduling. The reason is the government also has told in all the command areas where you have excess water, how you can pump into a ridge area and how circulate areas with using non-conventional energy. So this is the challenge. So you have satellites today to tell about the incoming solar radiation and what is the optimal way of planning your solar power plants, and that in distributed areas which you can do very efficiently. That means you are putting the excess water and then trying to cover the ridges also and bring more area into agriculture. And one more example which is done, which could be done in 3 days with the public domain data is the government looked in 2015-16 in second green revolution in Eastern India. What does it mean? Second green revolution and in this thing. See, the statements you have to underline. So you had a little read into the government documents in terms of each ministry. What is that they're looking for? Where is the need? And what is the data which is already existing? Don't invest onto data too much. And on that, what you'll do a process and then show an example as a product, as a service, which you'll do. And the product here is too big a money than what you're looking in making satellites and rockets. Normally, whenever you talk about space technology and all, you look at that there's a lot of money in that, but then the applications has a bigger money to play a role in such. See, this is where already there's a land use, land cover information map at 1:50,000 scale and 1:250,000 scale available on public domain. Shows you how much area is under Kharif, how much is under Rabi, how much is the summer crops. Your job is just to analyze and see where is the Kharif fallows in Eastern India. It just takes only 3 days. It took only just 3 days. But government cannot do regularly. Someone has to do that. And immediately those areas, but we have to look in where AI and deep learning comes, whether the same areas under fallows, how people are managing. And that is means there's a potential versus a suitability. There may be a lot of potential, but that doesn't give you results in terms of it is a feasible. So you have to differentiate feasibility. And within that feasibility, it could be done. The very next year, the pulses rates have dropped. That means what did we do? We didn't do the product chain. That means what are the pulses extra which has come? How do you manage? How do you distribute it? How do you sell it? This is where you have a greatest opportunity in terms of, we all talk about Amazon, Flipkart, etc. But then here is your business. That means you know GIS, you know a little bit of Python programming, and other things you can put through. One example just to trigger you, I'll give you on Geo Manrega. You're all about Rural Employment Guarantee Scheme. That is a 30,000 crore scheme when we started, where we got in, and we suggested that we don't need extra inputs. But with existing your input of the mobile, what is existing, how you can tag which is the person, what is the work which we are doing. You kindly go into Bhuvan and go into Manrega and then get into that site, and you will know in each village how many works are being done. Good. Government told go for convergence. Convergence means that should benefit soil and water conservation. Because if we don't conserve our resources, and there's a degradation, then the poverty levels will rise in the rural area. That is the background of this.
Excellent.
So, Ramanan, I'm just concluding with this triggering statement only.
Sure.
So, now in the our pandemic season, this has been raised to 1 lakh crores for this data analysis to give what impact it has created in water or soil conservation. If you ask for 1 paisa, where are you? You look in. You are how many crores of business you're going to do. So this is where the potential lies in geospatial technologies and the analysis. And geospatial technology is not just from space, it is from drones and even your mobile, which has all the 3 systems put together. Thank you, Ramanan. I hope I had triggered few areas just to give a feel. Yeah.
Oh, thank you so much, Dr. Krishnamurthy. I thought that was a wonderful, very practical view into the opportunity for innovation using geospatial information systems. Like you mentioned, every aspect, you have to look at it not only from the point of view of where it can be applied, but also how it can create a source of investment, how you link together not just the ability to be able to improve agriculture productivity, precise irrigation management, but also the water management, the solar management that is required, and all of this information is available through the satellite-based information. We also talked about 3D maps and how it is easy to develop mobile applications leveraging the 3D technologies. You also talked about government schemes, which can be tremendously aided by leveraging spatial information systems and doing innovations and developing applications in that. I thought it was fascinating insight into the various possibilities of how we can leverage AIS information and satellite-based information. And there is a lot of wealth of information available. Like you also mentioned, don't reinvent the wheel, use what is already there, and be able to leverage that for the purpose of developing your innovation rather than trying to think that you have to collect all this information all over again. Thank you so much for the insights. I now turn over to Dr. Jayan to share his thoughts and views. We have had an excellent insight into both AI, robotics, as well as in geospatial information systems. If possible, Dr. Jayan, you can throw some light on the propulsion challenges and some of the areas, but I leave it to you to talk about areas that are very specific to your interests. Mr. Jain, you're on mute. So can you unmute yourself? It is still muted.
It's not muted.
Yeah, now it is fine. Go ahead.
Okay. Thank you very much. And good morning, very good morning to all of you. I am from the Liquid Propulsion System Center, which is primarily responsible for the development of the liquid propulsion systems for the launch vehicles and as well as the satellite propulsion systems. So here I'll be talking on the new directions in the area of the propulsion. If you see last 5-6 decades, if you see the propulsion area, there has not been, almost it was in a stagnant condition for quite a long time, because we always had the conventional propulsion systems like the solid propellant, then the general storable propulsion, cryogenic propulsion. All those things were developed a few decades back, and there was a stagnant zone in this area for quite a long time. But if you see that today, maybe 5 to 6 years back, totally a new focus has come on the area of the propulsion, especially in the liquid propulsion area, because of the new objectives and the new focus, which is, or new challenges in the area of the launch vehicle. So you know, the present day propellants, they are having a very large environmental impact. If you see the hydrazine-based liquid propellants, which is very, very commonly used, very highly toxic and carcinogenic and extremely difficult in handling in the storage facilities, whether it is a test stand or launch site and spent stage impacts, everywhere there is a very, very difficult to handle, and it is very, very unsafe for the people who are working with it. Then another thing is the environmental impact of the exhaust gas. If you see, either the solid propellant or if you see the hydrazine-based propellants, the exhaust gas is having a lot of either the hydrogen chloride or the carbon monoxide or nitrous oxides, which are all having very serious environmental impact in terms of ozone layer depletion, greenhouse effect and things like that. But these things are never addressed seriously in the past. Mainly the launch frequencies is very less, and you know that the number of launchers considering any other, whether if you take automobile industry or the aircraft industry, this industry, the launch frequency is very less. So this aspect was not considered very seriously. But today, you all know the launch frequency is increasing exponentially, and the time is not very far that we will have an everyday launch in the international scenario that will be there. So now today we cannot forget this aspect of the environmental impact of this propellant. So this issue has to be given very, very important, good importance, and all spacefaring nations now today are working on this green propellant or the reduced hazard propellant, because we cannot tell that the hazard, whatever we use, it cannot be zero hazardous propellant, is not possible. So some people call it as a reduced hazard propellant also. So basically the requirement is to mitigate the environmental impact, the impact to the people who are handling it. So there can be some compromise on the performance also. Generally an 80-20 logic, people tell maybe an 80% performance with a 20% cost with a less hazard to people and environment. That is the new direction in which the propulsion community is looking for. So ISRO also has started working in this area in a very elaborate way. So if you see a green propellant, so generally now today we use a solid, or in the liquid area we use the N2O4 or UDMH or N2O4, the monomethyl hydrazine, all are hydrazine based fuels, or even the LOX kerosene and the cryogenic. They are a little closer to the green propellant, but they are having its own issues, technical issues. And satellite, the liquid propulsion area, we are totally based on the hydrazine based, either the monopropellant system or the bipropellant system with hydrazine based or MON3 and MMH, all those things are only used. So now, as I told, these are all having very, very large impact on the environmental aspects and the safety. And today when we are talking about the human space missions, again, the large additional safety precautions are needed to use this type of propulsion systems, which will again increase the cost and the complexity will increase. Basically, these propellant combinations we selected at that time, mainly they are having good performance, and another thing is hypergolicity. They are very easy to ignite. There is no external igniter required. So especially for satellite propulsion, this is a very, very added advantage, because in pulse mode you use a thrust for station keeping and other things. So the ignition delay becomes a major criteria. So hypergolic propellant. So that is why we are using. So how to bring out a new propellant which is having the performance, moderate performance, and which is having all aspects which can work in a satellite propulsion or a launch vehicle propulsion with a reduced hazard. That is the motto, or that is the direction in which we have to work. So a green propellant, what it is okay, basically it's a very simple thing, a less hazardous, less toxic and easy in handling. It is very easy to tell, but to generate propellant that which meets the demands of the propulsion and having a less hazardous, it is a little difficult. There are technical issues in this. So what are the advantages? One is low toxicity, very easy to handle, then lower environmental impact. The pollution will be very less, even the ground facilities, test stands, launch site, everywhere. And because of all these things, the cost also becomes very less, because once the handling becomes complex, the facilities we have to provide will become more complex, and our cost is always high for such systems. So green propulsion systems, finally the cost also, there will be a very, very good improvement in the cost also. So now, if you talk about a launch vehicle, using the green propulsion for launch vehicle, today if you see the LOX liquid methane is the most promising option. We can see that till now, we were never talking with the methane as fuel. We have developed many systems like LOX LS2 engine, LOX N2 over UDMH engine, LOX kerosene engines. But till now, nobody has talked about LOX methane engine. So basically, the reason is we were always talking about expendable launch vehicle till now. So the launch cost is very high. A single launch vehicle cost is for a single launch because the vehicle is not recoverable. So there the payload optimization is a key objective. We have to have the maximum best payload mass in a single launch to reduce the cost, and the hardware cost also has to be as minimum as possible. So what we will do, we will select a propulsion system which is having an optimum performance, which can give the best payload. So that is a key objective in a expendable launch vehicle. So what we did, we used the respective propulsion systems with the best performance corresponding to its usage, where it is used. In a launch vehicle, we use a solid or restorable or semi-current in the lower stages, where the propellant is having a very good density impulse. You know, the density impulse is better, means we have the hardware mass will come down and the payload mass will go up. So they are the best suited for the lower stages. When you come to upper stages, where the propellant mass requirement is less, because the entire mass is already shed, so the mass of the upper stage is less, so the thrust requirement is less. There we use for a high performance cryogenic propulsion system with the best specific impulse. So this was the direction in which the propulsion community was looking at to optimize a launch vehicle. What is the propulsion system we selected? But today, now the direction has changed. We are going for a reusable launch vehicle. We know that the re-entry problems are being resolved, or some people have already resolved, and we have seen the launch vehicles spent stages beautifully landing on water as well as land, and they are being reused a number of times. So now in a near future time will come that expendable launch vehicle will be totally leaving this scenario, because once a reusable launch vehicle is developed, the cost comes one order low. From the $20,000 to $25,000 per kg, it will come to the $1,000 to $1,500 per kg. So there will be no space for an expendable launch vehicle. So now we have to, so once the requirement changes, we have to also look for the options on propulsion to handle these new requirements. So from an optimum performance system, now we are looking towards a reusable system. Which system is best suited for use? We are talking about 50 times reuse or 100 times reuse. And with the what is more important is this reusability also. We should have a very minimum turnaround time. We should have a very minimum refurbishment cost, because economics tells finally you have to recover the stage. There is a cost involved in the recovering the stage. There is a cost involved in the refurbishment, and there is an impact on the turnaround time. So these things should be compensated by the reuse. Then only or a new stage if you develop and a reuse, the economics has to match. So for this purpose, the propulsion system should be very much capable of reusable with a very, very less turnaround time and less refurbishment. So there only we have to look for a propellant which is having a very good reusability prospect, easy handling, very low cost propellant, less environmental impact and moderate performance. That is the key to it. So till now we are looking for an optimum performance, but now we are looking for other aspects. We are giving more weightage, and it should have a moderate performance. Need not be the best performance, because a LOX methane propulsion system cannot have a performance as a cryogenic performance system, or it will not having a better density impulse as in a semi-cryogenic system. But this is having a moderate performance, fairly good density impulse, fairly good specific impulse. So we can use this in a single propulsion system launch vehicle. Today the concept is, earlier we were using multi-stage with multiple propulsion systems. A single launch vehicle will have 4 or 5 different types of propulsion systems. There will be a solid, there will be LOX kerosene, there will be a cryo will be there will be a restore will be there. So this is the type of vehicles. But today we are looking at a single propulsion system launch vehicle, a mass production. So there again, once we look into that direction, the LOX methane is the most promising option. We are already seeing that the future launch vehicles, now the launch vehicle scenario is totally changing. The future launch vehicles, the Starship, if you see, or the New Glenn, or the Area Next, all vehicles, the future launch vehicles which are going to be in the market for maybe a long time they are all using the LOX methane engines, either the Raptor engine or BE4 engine, Prometheus engine. This engine development is going in full swing, and in a near future they are going to fly, and for a long time this and all other propulsion system will be vanishing from the scene. So, there are problems with locksmith and technologies. Other systems, a lot of data is available, a lot of flying engines are there, but locksmith and technology, everybody is in the process of development, not much data is available. So technology demonstration engines have to be realized. We cannot directly go for a development of an engine, because there can be unforeseen problems. There can be new issues which have to be resolved, especially with respect to combustion, cooling, ignition, starting, all those issues you have to resolve when you go for a new propulsion system where you don't have any data. So generally we will have to go for a subscale type of engines or a technology demonstration engines and try to understand the performance, generate maximum data, then use all this data to design a very optimum type of a launch vehicle. So the demand is very huge. Low thrust engines we need for the upper stages of small vehicles, because upper stages of vehicles finally for injecting multiple satellites we need the low thrust engines. Then the 80 to 100 ton thrust or medium thrust engines, because now instead of going for a very high thrust engines, what people do is having a medium thrust engines with clustering. This is how a number of engines will be clustered. Same engine will be clustered in a core stage as well as an upper stage, depending upon the thrust requirement. So this is so ISRO is also working on a technology demonstration engine using an existing cryogenic engine systems are used, and trying to understand the technological problems, the performance issues related to LOX methane. And then we are also planning a 3-ton, a small thrust engine, 3-ton engine with a electric powered motor, a state of art with a full 3D printing. Then maybe a 80 to 100 ton thrust engine we are in the drawing board stage, which can be which will be used in the heavy lift vehicle, a reusable vehicle for interplanetary missions and heavy satellite launching. So as far as methane is concerned, as I told, the advantages are a lot of advantages. First of all, it is a very green propellant, easy handling, safe, less environmental impact. So this, that way it is a promising candidate. Then it is having a moderate performance, as I told, in terms of specific impulse and density impulse. Then easy availability and low cost. Then reusability, that is the key. There is the soot formation. The semi-cryogenic engine is also, okay, it can be considered as a less hazardous, but there the problem is reusability is very difficult, because we are having a soot formation, then there is a coking, carbon deposit formation in the channel, then it is not having good coolant properties, so thermal management is difficult. So because of that, the number of first of all, the number of cycles of reuse will come down drastically. Second thing is, between the flights, lot of refurbishment required. All this carbon formed carbon has to be removed by scraping. So lot of refurbishment activity, and that involves a lot of cost also. So the attractiveness of reusability will come down, and it is and methane is a very safe. Even if hydrogen is a very good propellant as a green propellant, because oxygen and hydrogen is a good combination, but hydrogen is not at all a safe fuel. You know, there is a explosive hazardous fuel. Then the LOX methane is having very much advantage, because the temperatures of LOX and methane are very close, so we can have a thermal management is very easy. Either you take the injectors or the turbo pumps or propellant tanks, you can have a common bulkhead construction of the tanks. Then one major thing is now you are talking about human explorations to Mars and other planets. So the present day we are using only satellite propulsion for that, and we are simply using the gravity. The orbital mechanics is used to reach the Mars. That is why we are taking 6 months, 7 months time. But when for a human mission, that is not possible. We have to go and come back quickly. So there we have to carry. If you use methane, you have to carry only the propellant for the onboard journey. Methane can be synthesized in Mars and oxygen also, and it can be loaded for the return journey. So this will make the launch vehicle a very simple system. And now coming to even the satellite propulsion also. Satellite propulsion, if you see, lot of propellants are being tried out by different agencies. But finally, when we talk the hydrogen peroxide, then ADN, the ammonium dinitrile, and hydroxyl ammonium nitrate, HAN, hydrogen peroxide, ADN, and HAN. These are the 3 areas where people have done serious work, and even ISRO is also mostly concentrating on these 3 type of propellants. Whereas there are people are doing research in many new areas. See, the issue is it should be very, very stable, and it should meet all the technical requirements in terms of hypergolicity, ignition delay, and it should not be having very, very bad performance also. Performance also matters, because if the specific is too low, there will be an issue. So if you see the, so first thing is, whatever hydras is monopropellant, there are two types, one is monopropellant, bipropellant. Monopropellant we are using for many of your satellites, IR satellites, hydrazine based monopropellant. You have to totally remove that and come to a monopropellant green propellant. So there either the hydrogen peroxide or ADN or HAN, all these areas, small thrusters, 1 Newton to 10 Newton type of thrusters for the small satellites, or the IRS type of satellites, or further small satellites in the SSL, now the small satellite launch vehicle are going to come. So there are all those things, low thrust engines with the monopropellant. So there the performance will be slightly lower than the bipropellant, but the complexity is, it will become very simple. Then we are also talking about bipropellants, green propellant. There the main candidates is hydrogen peroxide and kerosene, or hydrogen peroxide and ethanol. These are the two combinations which are having serious attention. So here again, if you see, we have to replace the N2 over MMH combination in our geosat and all communication satellites we are using. We have to replace that. So then, in the international scenario also, you see large work is going on. This type of, you can see the green propellant infusion mission, then using the hand-based oxidizer and fuel blend, and high performance green propulsion by Sweden, ADN-based. So like that, a lot of activities are going in the international scenario.
Yeah. So I think you have provided a fantastic insight, because we had planned this till 11:30. So if you want to conclude it with some particular final statement on the propulsion opportunity. Hello.
Sir, can you repeat?
Can you repeat?
Yeah, I just because we are overshot of time by 15 minutes.
It's okay.
But if you can conclude on the opportunity as well as the innovation capabilities that are there, because you are given
That's what I'm telling. Yes, sir. That's what I'm telling. So the main opportunity lies in, one is the LOX methane engine development. As I told, LOX methane engine development is having a wide variety of applications, starting from a upper stage low thrust to a 80 to 100 ton class of an engine, which is having a large reusability perspective. That is one area where a real development effort has to be. Second thing is these three areas. That is, one is a very small thrust monopropellant systems like a hydrogen peroxide system or ADN based or HAN based system, where we have to tackle some of the issues we have to tackle by the real chemical analysis. We have to find the best catalyst, and we have to find the best stabilizer, because the storage for a long time is always a problem for self-decomposing propellants. So that has to be handled. The suitable stabilizer, suitable materials to handle this have to be identified, and this system. And second thing is, when you go for a crew module type of, now we are going for human space mission, a crew module type of propulsion system, when you go, again, this green propellant becomes a real requirement, because all other propulsion system, there is always a disadvantage of the impact for the crew. So when we go for a green propulsion system, maybe a 100 Newton class of engine for either a hydrogen peroxide based system or a bipropellant with hydrogen peroxide or ethanol, these type of systems for future and present and future human space mission, they will be an absolute necessity. So these are the areas, but only thing is, to conclude what I tell is definitely green propulsion system is the future of the launch vehicle and spacecraft propulsion. So we have to concentrate on, for launch vehicle we have to concentrate on LOX methane, for satellite monopropellant and bipropellant combination using the specified propellant. So only thing is the issues with respect to hydrogen peroxide, if you take long storage, handling, materials, purity, all these things are issues. So these issues have to be handled, and this type of development has to be taken up.
Thank you. Thank you so much, Dr. Jayan. I thought that was very, very informative. You brought out all the aspects of what are the challenges, not only in the current propulsion systems, but what green propulsion means, as well as what are the opportunities from the long-term point of view, where we are looking at futuristic solutions also which are required in the green propulsion systems area. You brought out many different facets of propulsion technologies that are required from the point of view of how can you make it less hazardous, less toxic, less environmental impact, easier to handle? How can you make them more efficient? There are many, many areas in which one could innovate, not only for meeting current requirements, but for future requirements. I want to thank all the speakers today, the panelists, for a wonderful exposition of the potential opportunities for innovation in the space area. I think this has been one of the most comprehensive webinar events, and though it exceeded beyond time, I did not want to stop any speaker because you were giving a wealth of information on the opportunities as well as the innovative needs in each of these areas, whether it is geospatial system, whether it is robotics, whether it is green propulsion systems, and so on. I want to thank Dr. Shyam for enabling from ISRO all the panelists, the distinguished panelists here. Can you put in mute, sir? I think, yeah. Okay, great. So I'm sure all the audience who have been part of this, and even others, this is all going to be available on YouTube. So we'll send a link to all the startups who have logged on and beyond. I think this is a tremendous piece of information that you have got on what are the opportunities, what are the challenges, not only for this particular ARISE challenge, but I'm saying even in future, there are so many opportunities that young innovators can innovate and make their solutions have an impact on all these needs. I want to thank once again Dr. Krishnamurthy, Dr. Jayan, as well as Dr. Sam Shyam for having participated in today's session. I hope all the innovators out there are going to apply their minds and be able to create solutions that the space sector needs, but more importantly, our country needs and the world needs. Please ensure that all your applications are submitted before October 31st. We are going to ensure that the winners get attached to incubators, to ISRO scientists, to domain experts, to mentors who are going to help them in their innovation. So it's not a challenge just by itself. It is an opportunity for us to work together to create innovations that are sustainable, that are marketable, and that will be deployed in the marketplace, whether it is by the government or whether by the private industry. So I think this is a wonderful opportunity where government, industry, academia, and research institutions are coming together to help you, dear innovator, in making your solution workable, deployable, and create a product that will create an impact. Thank you all so much for joining in. I do hope every one of you continue to be safe. And once again, my heartiest thanks to all the distinguished panelists and to Dr. Sudhir for enabling this. Thank you so much.
Thank you. Thank you, sir.
Thank you.
Thank you. Thank you.